Okay, we're on the VR-8 now. A lot of you might remember that Haas used to have VR-8, VR-9, and VR-11.
Yes.
This is a lot different.
It's a very different machine.
It's called
from
the
those
same thing, but
models. And I'll say right here at the top that if you have a VR-8, your programs will not run on this machine. That VR-8 was an A-axis mounted on a B-axis on the spindle head. This machine, like the GM2 5-axis, is a B-axis mounted on a C-axis. You can't just swap the axis letters and run that old program.
That will not
your
work.
post-processors for your old VR-11 are not going to work with this machine.
And maybe, can you jog the spindle head down a little bit so we can get a look at how the head is on these machines. So we've got a VR-8, a VR-9, and a VR-11. They all have 40 inches of Y-axis travel, so the difference comes in X-axis. So this machine has 64 inches of X travel.
The VR-8 64, the VR-9 is 84, and the VR-11 is 120 inches of X-axis travel. Other than that, they're basically the same machine. The Y is all 40 inches. The Z-axis has more travel than the VF series that these are based on. Those are 30-inch Z-axis machines, but to accommodate the 2-axis spindle head, we had to raise everything up. So we have 42.5 inches of Z-axis travel on this machine.
Right, and you can actually see if you have a VF, got this extra section of sheet metal enclosure here. That's that extra travel that John
we
just
basically
talked about.
raised the top end of the machine up on risers 8 inches and then accommodate everything with different parts.
So I know I talked about this on the GM 5-axis, but I want to talk about it again. Any 5-axis machine, you really need to be familiar with the machine layout drawing. So not just for these machines, but any machine, you go on HaasCnc.com, go to whatever machine model that you're looking at, and find the machine layout drawing. It's right underneath the hero image, and be familiar with the work envelope of the machine before you get started.
Yeah.
Okay, so let's talk about the spindle.
Yeah, so first off, the spindle head assembly on this machine has got the same configuration as the GM2 5-axis, right? So it's a C-axis mounted on the Z, C rotates about Z, and then a B-axis here tilting in the front, and the spindle is mounted on there. So that other machine was an HaasCnc F63, which is basically a router tool holder. This machine is an HaasCnc A63, very different, not interchangeable tool holders at all.
It sounds similar, but it's very different.
It looks the same, it sounds the same, it's not the same tool holder at all. So this takes the HaasCnc A63 tool holders, and it's also a 20,000 RPM spindle, but it's got more horsepower than the spindle over there. So
we'll see that when we go to the cutting demo.
Yes, exactly. That spindle was 16 horsepower peak. This one's more like 24 horsepower peak. It's got 20 horsepower continuous, like I said, 24 peak at 60 or 40% of the duty cycle. It also is grease pack lubricated, so you can use it on materials that can't get contaminated with oil. And it's also liquid cooled and has a spindle chiller mounted on the back of the machine.
Okay, so that's the spindle. Standard features, let's just go through them real quick. We have a 50 pocket tool changer standard on this machine. Standard
50, it's the only one that's available on this machine. It comes with the coolant system, chip auger, and also the probing system. As we mentioned on these 5-axis machines, they all come included with the whips probing.
And it also has a 95-gallon coolant tank.
Yeah.
Standard on this. Okay.
Like the GM2 5-axis, this thing's got all of the 5-axis software features added in that we talked about. There's dynamic work offsets and tool center point control. The VPS template for setting MRZP, machine rotary 0 point. Also VPS template for setting the safe zone. This machine has safe zones established as well.
Works just like the GM 5-axis.
Just like the GM2 5-axis. There's a few less things to run into on this machine than on the GM, but yeah, it has the same feature there. It's got a feature coordinate system. So both of these machines have what we call the feature coordinate system, which is G268 code. G268 essentially, people may call it tilted plane or custom plane, but it allows you to define a plane of rotation based on where the B and C axes are positioned. So we have that feature coordinate system included in the software features. There's also vector jogging on this machine and planar jogging, which is a new feature that's available now on both of these machines, or not available, I mean it's incorporated on both of these machines.
Right. So maybe you can explain a little more about the tilted planes or the G268. Maybe we can jog the spindle head and kind of show everybody what you mean by that.
So the first thing I'm going to do is jog my B, get it somewhere out here, and then I will rotate my C around, get it to some compound angle like this. You can move over a little more in the work envelope so I don't run into travel limits. All right, so my head is now at, where am I at? B is 38 degrees and C is 43.9 degrees. I can use V and J and handle jog to go into vector jogging mode on this, to jog the tool, and I'll do that here. V, J, handle jog, and you can see that the head moves as it did before. Now, if I come back here and I press the P and J and now handle jog, this brings me into planar jogging mode. We have a new tab in current commands called plane. So in current commands, I come up here and move over to, to plane. So here we have the work offset, the current work offset, tool offset, and values for I, J, K, Q codes. Also, the origins in X, Y, and Z. We have a set of commands over here on the right. My head is tilted at the angle that I want to jog in. It's tilted to the plane that I want to jog in. That's how I should have said that a little better. So now I just have to press the F2 key, and that sets my I, J, and K, which defines the plane. So now the machine knows that I want to jog in that plane, and now I can select the P, J, and handle jog buttons.
That's vector.
Cancel. P, J, and handle jog. Now I'm in handle jog mode. I can select the Z axis, and I'm in vector jogging. Hopefully you can see that.
Yeah,
jogging along the vector. But now I can select the X axis, and I'm actually moving along the X axis in this plane that I define.
So again, you have defined that plane, and now you're back jogging in traditional, at least on the machine, you're asking either X, Y, or Z, but the machine knows your plane is tilted at that angle.
Absolutely.
And it's jogging accordingly.
And what that really does for me, so I've got this plane here that's my XY plane, G17. I've tilted it up here. My cutting tool is here. Now I've set my plane for jogging mode, so now that I can jog Z like this, X like that, and Y like this. The great thing about that is it allows me to establish a 0 point in origin. So when I was here, I had a work offset that was the corner of my plane, right? There's my G54 was there. My new plane is over here. I can, with an X, Y, and Z of 0, my 0 point is still at the work coordinate, but I'm jogging in these axes like this. If I add an X, Y, and Z position move on my G268 line to get me to this corner, now this becomes my 0 point in my plane where the tools are like this.
In your newly defined plane.
Yes, and the great thing about this is if I have a workpiece that's already got an angle on it and I indicate or I find out where that plane is, now I can program machining features like drilling holes, doing arc, 2D arc, G2 or G3, circle interpolation,
right,
and cutter compensation. All of those things that used to be only for 2D in the G17 plane now work in these custom planes. So it simplifies programming, and also I have the ability to jog and move around, and I can actually manually machine some features in this plane using the X, Y, and Z jog keys and paying attention to the X, Y, and Z coordinates. If you look up here in the plane tab on the screen, hopefully Frank's got it up over there still, you can see my current coordinates in the feature coordinate system.
Cool. Okay. What else do we want to cover on the VR-8 here before we get to the demo? I know we got a cool cutting demo, but...
we talked about planar jogging. Oh, I wanted to mention setting 335. So
That's right.
For about a year now, we've had a new setting in Haas next generation controls called linear rapid mode. And essentially, it can be set 3 different ways. In a G00 rapid move, all the axes that are programmed to run in that command, to move in that command, in all Haas machines built since the beginning of time have been, all of the axes start traveling at their maximum speed towards the end point, and the axis with the shortest distance to travel stopped first, and the axis with the longest distance to travel continued. So you'd end up getting a dogleg rapid, right? The only way to make it start at one point and end at another and travel in a straight line was to program a G01, linear interpolation.
Right.
With the linear rapid mode, you can now set your machine to travel in a straight line. All the axes in that rapid position move will start at the same time and end at the same time.
So even if you've got X, Y, and Z
Yes.
all in that line.
All in that line, they'll travel in a straight diagonal move instead of 45 degrees and then another one taking off.
And
so
that's important because now it's much more predictable.
Yes, yes. As soon as the tool starts moving, you can really predict where it's going to travel. Where, if you're looking to miss a clamp or something,
right,
as you're rapiding across the top of a fixture, it's very important for that. There's also, so that setting has 3 positions. There's none, which would mean your machine would position just like all Haas machines up to this point. You can set it to linear XYZ, which means only the X, Y, and Z. On a 3-axis mill, it doesn't really matter. But if you happen to have a 4th-axis rotary, the rotary wouldn't be included in that. And then the third setting for setting 335 is linear plus rotary. And that means that all axes on your machine that are commanded in a G00 position move will start at the same time and end at the same time.
So a machine like this,
Yeah.
or even a regular vertical with
the
a
whole
trunnion.
reason I bring this up is
Yep.
that Haas machines are going to start shipping with linear rapids on. So there will be a little bit different behavior in a new machine that you get from the factory. Setting 335 will let you revert back to the old way if that's the way you want to do it. But believe me, especially on 5-axis machines, once you've used linear rapids with linear plus rotary, you'll be sold and you'll never want to go back.
You'll never go back.
Yeah.
You'll never touch that setting
Yeah,
again.
exactly.
Okay, so you've done a really cool demo. Sal, if you can get in on this demo, you want to talk about a little bit what it is before we watch it?
So essentially it's a block design that we came up with to show off the features of the machine. So we needed undercuts, right? So we milled out the front. We started with the block. You'll see it in the video. We've got undercuts in the front and then cut angles, a top angle and a bottom angle. Down the center, we put a channel with some sweeping curves and then tilted that wall so we get a 5-axis simultaneous swarp tool path across there. This is not the best surface finish part we had, but the one of the machine's a lot better. It looks much better than that. And then we're drilling and tapping holes on all of the angled surfaces. So you can see there's compound angles on the end, straight angle on the back,
Yep.
and the sides.
Yep, we've got tapped holes here on the top and on these angles here as well.
Yeah.
Okay, Frank, can you get that video queued up? And John, if you want to go over there by him and kind of narrate
Perfect.
through it.
So my workpiece there is 3-inch tall, 5-inch wide, and 15 inches long. It's 6061 aluminum, and I cut a dovetail on the bottom so that I could hold it in our new Haas HS CV5-05 self-centering vise, along with the 4-inch riser. All right, that allowed me to get it up off of the table so that I could tilt over and cut this thing at 90 degrees. The first tool that's running there is a Haas HS6 NP 3-inch 6-flute shell mill. It's running at 6287 RPM and 315 inches a minute. Chip loads 8.5 thousandths. It's a 90-degree cutter, and the inserts each have 6 edges on it. So this is brand new on the website last couple of weeks, but it's a terrific cutter and really ripped this material. You'll see we're facing all 5 sides of this material to get our stock down to the final size and the height dimensions. You'll notice throughout the video that the coolant comes on and then shuts off again. Well, that's just me pressing the coolant button, trying to keep the coolant down for the video so that you guys can actually see what's going on. So you'll see sometimes the coolant's on, sometimes it's not. Here's a 3/4 inch 3-flute aluminum. Again, this is the Haas end mill right off of our website. This is running at 20,000 RPM. It's 5 thousandths per tooth, giving us 300 inches a minute. The widths and cuts vary throughout this, but basically it's taking 712-inch width of cut and 190 depth of cut. So you can see we're roughing undercuts and then putting the angles on top. Let's see, there's a cutout through the middle I talked about when we were looking at the part earlier with sweeping curves, so we're roughing it there. You can see now we're going to tilt over and come in and do the full 5-axis swarf tool path on that. And after this swarf is done, we're going to come back and face mill the corners. We're putting a compound angle on each of the 4 corners. Drilling, chamfering, and tapping will be coming up next. The tapping was really interesting. It was very easy to program. We used a non-vertical rigid tapping cycle, and then went and got a plug gauge out of QC and came over, and man, those holes were so tight. So perfect. The fit was really snug. That thing wouldn't really jog around in there at all. The plug gauge really came out great. This machine is terrific. I enjoyed working on it very, very much.
All right. All right. Thanks, John. Frank, are we back? All right. Thank you, John. So look at the GM2 5-axis, the VR-8. Encourage you to go on HaasCnc.com and check out the pages. There's a ton of technical information on there. If you go on the product detail page, we call it, for each machine, there's a tab called Details. And you guys put a lot of information in those details tabs.
Yeah. A lot of the information that I kind of breezed over in this about G268, custom planes, and other codes that are available on these tilting head 5-axis machines are in those detail pages on all of the models for the VR-8, 9, 11, and GM2 5-axis.
Right.